All right, greetings everyone, Stoller here, and today we are going to be learning trigonometric substitution and how to do it. So, without further ado, I'm going to get right into it. If you have not already taken Calculus 1, you should probably review Calculus 1 before watching this tutorial. Okay, here we go. So say we have an integral from 0 to 1 of, let's pick anything, x over square root of 4 minus x squared dx, of course. That's just something you never forget. Okay. So what we have to do is we have to solve this integral. But how do you solve it? You can't do u substitution. You can't just standard solve it. Well, how do we do it? Well, it turns out there's a way. All we have to do, I'm going to just teach you the shortcut here. X equal to, in this case, because it's a minus sign here, we have x equals a sine of theta. What is this, you might ask? Well, we know this for sure. And we have x equal to some sine theta. Well, what is this? This is where a is equal to this coefficient, the square root of this coefficient, which is 2. And this is a form. So in this form, when you have a squared minus x squared, we use sine of theta. All right? So why are we doing this all of a sudden? Why are we substituting this in for x? Well, because you look at this bottom here and you think, gosh, if only this were a sine or a cosine, because, square root of theta plus cosine square root of theta equals 1. We know this. And you think, oh God, if only this were something else, don't this were like a sine or something. Turns out we could substitute a sign in. And how this works is we have first we have to calculate the dx, because of course we got x, but we can't take the integral with respect to dx anymore because we're going to be taking it in respect to theta. So we're going to have dx is equal to 2 cosine of theta. And from 0 to 1 of x over 4 minus x squared, square root of 4 minus x squared, dx will then become integral from x equals 0 to x equals 1, and then we're going to substitute all of this in. So for the top, we're going to substitute x. So that is 2 sine of theta divided by the square root of 4 minus 2 sine of theta all squared. And then we have to substitute this in for the dx. Oh, of course, 2 cosine theta d theta. That's something you should never forget. So we have 2 cosine of theta d theta. Let me scroll down. Okay, so then what we do is we start simplifying. Get 4 sine of theta cosine of theta divided by square root of 4 minus 4 sine squared of theta d theta. Does that look simpler? You might say, no, it doesn't. What are you doing? But trust me. X equals 0 to x equals 1. And here's what we can do now. Get a 4 here, you get a 4 here. What is the square root of 4? It's 2, right? And what do we have in these two factors of 4, right? What can we do when you have two factors? We can factor it out. So let me show you what I mean. I'm doing a poor job explaining that, but proof is in the writing, or the math in this case. Square root of 2. Hold on. Now we take this out of the square root. Sorry, I wrote a 2 before. I had meant to write it outside of the square root. 2 square root of 1 minus sine squared of theta d theta. And if you recall, the previous expression, sine squared of theta plus cosine squared theta equals 1. So cosine squared theta equals 1 minus sine squared theta. So what we get is Look at that. Now is it starting to look a little better? Well, here's how to make it even less daunting. So this 4 and this 2 cancel. Well, they don't cancel. You just get a 2 at the top. I always like to use the term they cancel. They don't technically cancel. But 4 over 2 is 2. So this 2 at the bottom goes away. And then you get cosine of theta. Theta. But that still looks complicated. These cancel. 2 sine of theta d theta. There we go. There we go. That's something a little less complicated, isn't it? So now we think, what's the integral of sine of theta? Well, the derivative of cosine of theta is negative sine of theta. So the integral of sine of theta is negative cosine of theta. Now we can't go evaluate it just yet. Sorry, I put this d theta here. This shouldn't be here. We cannot evaluate it just yet. What we have to do is we need to get this back into the right, because it's still in theta. It's still in theta. You can't have it in theta. You gotta have it in x. So what we need to do is we need to go and look at what we had above here. We have x equal to 2 sine of theta. So x equals 2 sine of theta. So sine of theta equals x over 2. Why do we do this? Well, this is a right triangle. This is theta. So sine of theta, it is the opposite over the hypotenuse. So the opposite over the hypotenuse is the sine, and so what is the opposite to this angle? Is this, and the hypotenuse is this. So now we want the cosine of theta, which is the adjacent over the hypotenuse. The adjacent is some angle C, some length C, that is. Sorry, excuse me for saying angle. Some length C. So how do we get this length C? Well, yeah, that's how we get C. So C, that's what C equals. Square root of 4 minus x squared. So now that we got this angle, excuse me for saying angle again. Now that we got this side length, gosh, what is my problem with saying angle? Okay, now we got the side length, we know cosine of theta. It equals the adjacent, which is our C, over our hypotenuse, which is 2. Okay, then. Now all we have to do is just substitute it in here. And we don't need the little x equals, because now it's finally in terms of x. These two cancel. Get negative square root of 4 minus x squared. So now we plug it in. So we got negative square root of 4 minus 1 squared minus a negative square root 4 minus 0 squared. I always like to put those little parentheses, but you don't have to. Okay, so negative square root of 4 minus 1 and minus a negative square root of 4. And of course, we can simplify that quite a bit. This is negative square root of 3 plus 2. So 2 minus the square root of 3 is the answer. And that's how you do a trig substitution. I will be giving more demonstration videos, but I just wanted to do this real quick. I'm a bit tired, so I'm making these stupid little things like saying that thing was an angle But I hope you found this informative, and I hope you found this helpful. All right, see ya.